Hi everyone, happy Sunday. In the last post, I spoke about DataFabric. The and came up with an analogy of how DataFabric is in relation to the services that built on top, as well as the endpoints and how the endpoints are related with each other. One concept that DataFabric is based on is the data catalog. And data catalog is the system of meanings or metadata that business can find their way around the data to find their requirements or their query with the speed, with clarity, and with the accuracy that they require. Data catalogs these days are based on GraphDB, and the subject of today is we are going to do some hands-on exercise as to what GraphDB is, how it works, how easy is this to build, what is the language, what are the commercial GraphDBs in the market. Those things we'll cover. So let's go right into it. I'll share my screen and start using this sandbox that is available from one of the commercial DBs called Neo4j. The sandbox from Neo4j is a commercial graph database, is the most established one around in terms of work. It's been since 2007 they've been doing this. This is their sandbox online connected to their database service on the cloud, which is called Aura. So I've created already username, password, and I'm there. Let's see what we have in this database of mine that is recently created. Match and return in. Okay. So we only have two nodes and one arrow. Okay, two nodes and one arrow, one relation. So this basically match and return, and similar to, let's say, select a star from user tables in Oracle or MySQL. Now let's get rid of everything and create a couple of new nodes here from scratch. We say match. First, we detach all the connections and then we delete them. That's as simple as that. Two nodes and one relations are deleted in 2 milliseconds. Let's see what we have here now. We don't have any node or relation. We start creating some node, then run a script that creates a whole bunch of nodes for us. Okay, let's create a vehicle first. As soon as we enter the semicolon, the list of existing node types are appearing. If you see, as soon as we go to enter, there are movie and there are person. These are the default node types. We create a new one, vehicle, and then let's add some attributes to it. Name, which is truck one. Okay, truck one, and weight. Weight would be, let's say, 12 tons, and or any other attributes we can add. Let's say year 2011. That's it. We close this node and we create it. That's how we created one label, one node created with 3 properties in 10 milliseconds. If we check what we have in our, let's say, user tables or whatever in the schema, we have only truck one created. Now we can create another node. Let's call it road, and then add some attributes to it. name for it doesn't have to be the same attributes. Could be very different type of attributes. Type would be a highway, and let's say location would be Ontario. Okay, we add the next note. What went wrong here? Road name doesn't have a column. We need a column here. Another node is created. So if we see our user tables and everything, all the schemas, there are two nodes are created. Let's change the name, change the color of this here to something different. It's looking good. Okay, now we want to add a relationship. How we add the relations? The cipher, which is the language created by Neo4j, and I'm using right now, it has a simple syntax for creating relationship. It says first you find your two nodes, match, meaning find or select, vehicle, find the vehicle. We add a pointer to it, which is V. I'll tell you why we do that. We find the vehicle that its name is truck 1. Okay, that's enough because there is only one name with track 1. Let's see if it finds it. Return R V. We already added a pointer or a name for this. It finds it. Okay, now we also find comma, another node we need to find in order to add a relation between them. What is another node? Another node is road. Road is already there listed. The name should be 401. Name 401. Okay. And then that's at second one is also matched or selected. Let's see if they find it. Return comma or find these two nodes for us. Yes, it is found, no problem. Now what we want to do, we don't want to only find, we want to merge them with a relationship. Relationship is as simple as the graph. Imagine we want to create it in a ASCII code kind of thing. Is the same thing. So vehicle connected to, and the relationship are by created with a square bracket instead of round bracket that are for nodes. Only we have these two types. And let's call this relationship runs, running, or runs on 401. 401, which is, we have already selected it, we named it R. Okay, so we are creating a new, we are merging these two or creating a new relations between V and R, and V and R are clear what they are. Let's see what now we have. Let's now return them, see the two nodes. The two nodes are connected with a runs on relations. These are as simple as that. I have a script that creates a bunch of sensible, basically graph database with maybe 5 or 6 nodes and number of relations. I have a script for it. I cannot run the script here. I need to go to my Linux and run a script from there. Okay. So basically, what I've installed here is let's clean this. What I've installed here is Neo4j that comes with a client side called, let's like something C++. is a client side called the Cipher Shell. Okay, so Cipher Shell comes with Neo4j. Let's start Neo4j. I'm not sure if I really need to do that because I'm not connecting to the my own Neo4j. I'm connecting to the database on the cloud. But just in case, Neo4j is already running. Okay, so I have to run Cipher shell, but I need to make sure that it's connected to my database on the cloud. I've created that already here. Why? Because it needs a long, basically, parameter, and I'll tell you why. What is these parameters for? So we are running Cipher shell as root with sudo, and I want some extra character. Let's get rid of the extra characters. All right, so we are running Cipher shell. The most important thing is the address of this database. That's the address. This is the protocol, Neo4j plus S. That's the protocol. This is the address. The only thing we need is the username and password. Password is long, so I have copied that. There, let's connect to our client, which is Cipher shell. Now, okay, we are connected to the Cipher shell. Let's do the same thing here. At the end of every command, we need a semicolon. Let's see what we have. We have vehicle and road. That's not enough. I have a script here that let's see my script. It's called Cipher1. Let me show you. Oh, the column exclamation mark doesn't work here. Let's get rid of that. Let's exit. Show you what on my screen my script is. This is my script. Simply remove everything, create a couple of nodes: vehicle, road, inspection, station, vehicle record, defect, and then create the relations between all of these. For example, as we see between the road and the vehicle, there are two relations between the same two nodes. One is running on or is on. The other one is after inspection is back on. Okay, so these are things simple, basically script. If you want to run that, I want to go back to Cipher client. And run this. Simply we say source Cy1. We run that. Detach all the nodes, delete all the nodes, and creating all these new nodes. Okay, so now that it's created nodes, let's list them. See what we've got. Match then return in semicolon at the end because we are at the client side. We have these nodes doesn't show the relations here, but the relations is there. Now we go back to our browser and we check. We could done it on Linux as well, but we go back here to our browser. We now say match turn in. Let's see what we've got after running that script. Okay, so this is what we've got. The defect, the records of a vehicle, of a commercial vehicle. A vehicle was running on 401, and then the vehicle got pulled one direction. Why this is yeah, the direction, it got pulled into a station, then which was a station was located on 401. Then the vehicle was diagnosed with a defect, and this defect was detected at this station. After the defect, it goes to the record of the vehicle, and then the vehicle, after repair Mr. Repair node, is back on 401. That's how logical is this basically relations. Now, what is a graph database? Basically, the promise of a graph database is that the physical model or physical implementation represents the board shape, meaning that as anything we see on board, it is implemented the same thing physically. Whatever that means, it shows that basically is the most optimum in terms of query. What the query we want to get from this compared to relational, this is the optimum, and it is very fast. Now, going back to our discussion on the DataFabric, basically, is what we need for the DataFabric. The most important one, in addition to the one the gentleman talked about, and I shared the clip, the endpoints and the services. Endpoints and the services on top of it, and the relations between the endpoints. What we really need to make all these endpoints sensible in terms of business is a data catalog. What is so imagine we are in a jungle and trying to find our way around with no GPS and no compass. Basically, a data catalog, the most important parameter or the foundation of a data fabric, is like a GPS. It shows business where the data is. It shows us, it shows, again, I keep using business rather than IT. It shows business to find its way around, and I'll tell you why. Because what we need to find, the criteria for a good data catalog as a foundation of data fabric, is that the business can find answer to their questions, or to their inquiries, to their requests, with the speed, with clarity, and with speed, clarity, and accuracy. With these three. This is how we basically do our data catalog. So a data catalog, basically, a simple definition I came up with, is a system of signs and directions in the interwoven ways of our data that guides business to reach information they need with the speed, accuracy, and clarity. Now, to create the data catalog, what we need is the metadata. What is metadata? Metadata is the data about data. Here, we are not talking about Oracle Dictionary that has the metadata. This is a different metadata. What we need is the meaning. The data, the meaning of the data needs to be clarified, captured, and represented. The graph database is one of the ways to reach the meaning, basically. Why? As we see, everything is related in the world, and graph database can show what is related to what and why. Okay, so To create the meaning for the data, or data about data, or metadata, the knowledge graph these days are trendy. A lot of organizations going creating their knowledge graph, the metadata in the way, and to show how the nodes and arrows are related, related to each other. Make that, and then make those knowledge graph actionable in terms of connecting to the real data. Another pillar of the data fabric is the data-driven culture. The data-driven culture is about involving more and more people as it is possible to enrich the meaning of the data and to make either activities and decisions based on data and based on evidence as much as possible. Encourage more employees to learn data handling techniques and get the data basically skills not out of the limited number of elite data analysts and data engineers. This way we can really make use of our data. Now, another subject is, where is our data? This is very important one. Where is our data? Is it only the production system where the data is being produced and downstream in the data warehouse? Yes, but there are a lot more to it. Our data is not only there. Our data is in the PDF file, in the spreadsheets, in the mind of people, in the code itself, the entity name, class names, their class hierarchies, the interface, class interface names, all those things. Let's start with one example. As a business analyst, we are working with, day in and day out, we are working with legacy documentation. Legacy documentation is where the data of an organization is also buried among other places. And let's call the legacy documentation is the pre-agile comprehensive documentation dump site. So this pre-agile comprehensive documentation dump site, how can we get things out of it? That there are ways. Organizations have already started utilizing NLP, natural language processing. Google has added a number of libraries to natural language processing that is being used, and is an open source. BERT, B-E-R-T, is one of them. I have the information that I want to show you with one exercise. So people are calling BERT libraries from Python and processing their text database, their text information, and grabbing lots of information from it, including something called name entity recognition. So name entity recognition is to get one text and then grab a whole bunch of things out of it, and to find out what is a location, what is a person, what is a code, what is relations, and all these things. Getting this basically information out of let me stop this, pause this recording, and then find that. Okay, I found it, and my screen is already shared. This is one library. The Collab Research is an environment from Google where you can access a lot of programming language without any environment of your own. And this is where there is a sample where their natural language processing basically library called BERT, B-E-R-T, is used. For example, if we look at the line from top, from the transformer we import pipeline. That's the one of the libraries that we can use. The function of grouped entity. The function actually is called named entity recognition. Okay, it says let's find the entities in this. My name is Sylvian and I work at Hugging Face company in Brooklyn. Let's find in this text we can find all the entities. If we run it, okay, because the thing is not already part of the transformers. Okay, we need to install transformer first. Transformers. First we install it, and then we call the libraries from it. It processed this text. Like I said, the BERT open source library from Google has already trained and know the quote unquote meaning of 800 million words. 800 million, that's not it's a lot of words, right? 800 million. So therefore we can trust and bring our text and get the things out of it. And if we need also train that with our own type of text, let's see the result. All this is happening is not to process this one sentence, is bringing all the libraries and the subroutines in to be able to get this sentence. We could also call a file here or read a file instead of that thing. Taking more time, 1 minute, 21 seconds already. But like I said, the Word file, Excel files, PowerPoint files, these are the things where the information of an organization, the knowledge of an organization are buried, and people need to dig down. When we are talking about comprehensive, okay, let's see, this is documentation. We are, okay, it found this. Completed in that sentence. We found Sylvian, which is a person, and the Hugging Face is an organization. Brooklyn is a location. Brooklyn is a location, so on and so forth. I have another one that have part of, in fact, is a longer sentence. It's part of my resume. I've already built that. There you go, this one. Okay, so it did run, and it found a whole bunch of things. Masoud is a person. Silicon Valley is a location. IT is an organization. A lot of things. So we could have added more entity type to this and find these things. Or for example, Unix is a miscellaneous. So a whole bunch of things. This is almost 2 paragraphs of my resume is there. Therefore, there are the ground is set and is ready that we can reach all those documentations, comprehensive documentations that are dumped in our basically corporate content system, bring them, gradually make them component content and make them related, or later after component make them entity related, and make the relationship out of it, make the knowledge useful, bring them into our data catalog, and establish our data fabric gradually. These are available, where for as a person, as a business analyst, for example, going through this comprehensive legacy documentation, I'll compare that to an archaeologist. We need to throw a lot of dirt out in order to find one thing valuable, a piece of artifact from 10,000 years ago, or something that shows, or a piece of things. So these are really, they are useful. We cannot throw them away. There are a lot of useful knowledge, but is a manual task, and you need to read a legacy comprehensive document of any of the systems, cover to cover, in order to understand a couple of things useful that you want for that. This is how, when the information are not topic based or not component based, they are just in the huge file comprehensive. These are the pre-agile, but we need to keep them, we need to get information out of it, and that extraction eventually needs to be automatic. I hope you enjoyed that. That's my Sunday.